So this cannonball is shot out of a cannon. Okay, there's the cannon. I think it needs some legs to hold it up. There we go. There's the cannon. And it's shot out with an angle of elevation of 25 degrees. So we could say that from the horizon, this is 25 degrees. And it's shot out with an initial velocity of 90 miles per hour. And of course, as soon as it is shot out, gravity is going to start pulling it down. But at the moment, we've got its initial velocity of 90 miles an hour. Find the magnitude of the horizontal and vertical vector components. In other words, this thing is, yes, we think of it moving like this, but that means that there is horizontal movement and there's vertical movement as it goes through its parabolic path. So this is going to be x, so we're trying to figure out that. And then going up is going to be the y. Well, we can take that y information, since vectors can be moved, and move it over here, so it's actually only this tall. And then use right triangle trigonometry to solve for x and y. So we would have sine of 25 is opposite over hypotenuse, so y is equal to 90 sine of 25 degrees. Likewise with cosine, cosine of 25 degrees is adjacent over hypotenuse. Multiply both sides by 90. And we've got x. So this idea shows up again and again. This is really the, when we change to polar, y is equal to r sine of theta and x is equal to r cosine of theta, but in a slightly different form, in a physics application. So 90 sine of 25, so the y is going to be 38.036, and then the units were miles per hour. So this is basically saying, if when that thing came out, it only traveled vertically, somehow the laws of gravity didn't work or something like that, it only went vertically, then vertically it's changing at 38 miles an hour. But it's also moving horizontally, so 90 cosine of 25 at 81.568. So the majority of its energy is propelling it forward, but some of it is pulling it up or pushing it up as well. And then if we squared both of these and add them together, it should give us the 90 squared. 38.036 squared plus 81.568 squared, and then 90 squared. So there's a little tiny bit of rounding error in these, but otherwise they're correct.